Hello, thank you so much for tuning into my YouTube channel. Today's video is going to be a tutorial on classifying handwritten digits using CNN or convolutional neural network. Let's get started and see how we could do that. As I said, this video is a tutorial on classifying handwritten digits using convolutional neural networks. The problem we're trying to solve here is to classify grayscale images of handwritten digits 28 by 28 pixels in size into their 10 categories, 0 through 9. We'll use the MNIST dataset, a classic in the machine learning community. It's a set of 60,000 training images plus 10,000 test images. The workflow will be as follows. First, we'll feed the neural network the training data, train images, and train labels. The network will then learn to associate images and labels. Finally, we'll ask the network to produce predictions for test images, and we'll verify whether these predictions match the labels from the test labels. We have solved this problem before, in which we used a network consisting of a sequence of two dense layers, which were densely connected neural layers. In this video, I am going to use convolutional neural network to solve this problem. And you can see this is the architecture of the convolutional neural network that I'm going to be using. Let's go to Google Colab and have a look at the code. So this is where I'm writing the convolutional neural network that I'm using, which is a stack of conv2D and max pooling 2D. This is the max pooling 2D and this is conv 2D. And you know that the max pooling reduces the size of the image, as you can see here. So you can see that a convnet takes as input tensors of shape, image height, which is this one, image width, which is this one, and then image channels. And you can see that the size of the image in MNIST is 28 by 28 and they consist of only one channel. Let me show you guys the architecture of the network. So that's the architecture. As you can see that the output of every conv2D and max pooling 2D layer is a 3D tensor of shape, height, width, and channels. The width and height dimensions tend to shrink as you go deeper into the network. Now the next step is to feed the last output tensor of shape 3 by 3 by 64 into a densely connected classifier network like those you're already familiar with. I mean a stack of dense layers, as you can see here. These classifiers process vectors that are one-dimensional, whereas the current output is a 3D tensor. First, we have to flatten the 3D outputs to 1D, and then add a few dense layers on top. We'll do a 10-way classification using a final layer with 10 outputs and softmax activation, which means it will return an array of 10 probability scores, summing up to 1. Each score will be the probability that the current digit image belongs to one of our 10-digit classes. Here's what the network looks like now. As you can see, the 3 by 3 outputs are flattened into vectors of shape 576 before going through two dense layers. Now let's train the convnet on MNIST digits. We'll reuse a lot of code from MNIST example in one of the prior videos. So here I am specifying the train images, the train labels, and test images and test labels. Let me fit this model. And I'm going to be using only 5 epochs because I'm just going to show you guys how to apply the convolutional neural networks to this problem. It's going to take a little while for this to be run. So the training is complete. Let's now evaluate the model. As you can see here, we have test accuracy and test loss here, but I just wanted to have it here as well. If you remember, in one of the prior videos, I have solved this problem, but in that video, I used densely connected neural networks. If you again remember, the test accuracy for that problem was about 97%. But as you can see here, the accuracy is 99%, which shows that the convolutional neural network does much better than densely connected neural networks. And that's about it. Thank you so much for watching this video. I hope you liked it and you were able to get something out of it. If you liked it, I would appreciate it if you could subscribe to my channel and also share the video with your friends. Thank you so much and have a nice day.